Hey everybody, welcome back to the Craftsman sander saga. And today I'm just going to run through real quick some of the things I've done since the last video on the Craftsman sander. I covered this briefly in one of my odds and sods videos just recently, but for those of you who don't watch any of those other kind of videos, I'm going to just do a quick recap of what I've done on the project that I was currently working on and talk about what we're moving to next, which is right over here. First, foremost, I've decided to completely abandon the main sander unit that I was working on. For those of you who haven't been following along, what was wrong with that sanding unit was this bracket right here on that sander was broken, and I decided to make this new bracket. I then discovered that the shaft that goes through this lower spool right here, or drum, was really kind of messed up. My theory is that at some point somebody had ground this shaft or done something really bad to this shaft, because the dimensions on this shaft are all messed up. I couldn't get a standard pulley to fit on here correctly. I had to shim the heck out of it. After doing all that work and getting it to run true, fairly true, what ended up happening next was I had a problem with the alignment where I couldn't get the dust shield to work correctly with the disc that was on there. So I just got so disgusted with that, I decided, I'm going to scrap that one and save what I can out of that one, because I picked up this one here for real short money just recently, and this one, it's got a problem with the motor, but it's fairly complete, but it's missing one of the adjusters for the belt tension and alignment and tracking. And these are pretty hard to come by, but as luck would have it, it's the same style that was in the sander that I had on here previously. So what I decided to do was I'm going to take all the parts out of that project number one that I can use. So I'm going to end up basically scrapping this whole casting on the other one and scrapping the base on the other one, and keeping a lot of the other components. So, for instance, I pulled this roller, okay, off of the other one because I wanted to take that unit apart and get the two brand new bearings back out. So I carefully pressed these bearings out. So even though these are cheapo bearings, they are brand new. So if I need to put them in another unit, I can. Then I saved the upper roller, which also has brand new bearings in it. That is going to be an exact swap out for this one. So that'll go in that unit. This will probably be an eBay item, because I did find that one of these sold on eBay for around 35 bucks. So somebody must have been missing one of these and needed it pretty badly. This stop, okay, also this one over here is missing the stop. So we can put that stop with that. This little sheet metal guard on the dust thing, if it's the same exact size, it's missing on this one. This I don't need anymore, and it has virtually no value. I've seen these on eBay for like 5 or 10 bucks and not selling, so I guess a lot of people don't lose those. So I'll double check on that just to make sure, but it's probably a scrap piece. This guard right here I don't need, but this might be something somebody's looking for. So this might be an eBay item. Little cam adjusters that I took out of the one we're scrapping, and I'm going to need one of these for over here. These are the little stops. They're just really like extra long grub screws with nuts on them to lock them. Looks like I've got those over there. These will probably just go with I'll just put these with my other assorted grub screws. That's just the bolt for the stop, okay. I also have this table right here is off the original one that I was working on. This is the table for the unit you see on here now, which I bought this one out of a garage, and it was on a rickety wooden table. So but I bought it just for this unit, which is complete and works really well. I really didn't have to do anything to this one. Basically bolted it to the stand, so I'm reusing the stand, I'm reusing the motor. I'm putting this unit on here. I just took this table off because I was curious. I wanted to see whether or not this table was an exact fit, even though this is for the newer unit, and it sure as heck is. So the beauty of a second table is I could either sell the table on eBay, or more than likely I'm going to offer it to whoever buys one of these sanders and explain to them that if they're going to use this sander in the vertical position, you need a table here. By design, what the manufacturer intended for you to do was they intended for you to take your table off of your disc, just loosen a bolt, slide this out, slide this in here, and then you've got a table for your belt. Well, on the like the nice Delta Rockwells, the old ones, the cabinet style ones, you have a dedicated table for your disc, which is bigger, and you have a dedicated table for your belt. So what you can do is if you get a second table, you can just put this table here on the upright belt and the second table on the disc, and you can go from belt to disc whenever you want and not have to stop and switch the tables out. So that's kind of a nice thing to be able to do. So this table's going to go with this one, and then this will be a spare table that I'll offer if they want. This table over here on this one doesn't look as old as this table and doesn't look as new as this table. It looks like it might be in between there somewhere, so that's interesting. This bracket that I made will obviously be scrapped, but I'm going to actually just fire this up and show you guys who haven't seen it what the deal is with this. It runs nice. I know that's obviously that belt's not the right type of belt for metal. I don't really want to make a lot of sawdust, so So actually, right now I could put this on the market as it is, and I may very well just do that to get it the heck out of here. So the current shortcomings on this sanding setup right here are on this stand, the adjustable feet are completely missing. Not that big of a deal depending on what kind of a floor you're going to be putting on. This is a nice and stable unit. It doesn't have a ton of vibration when it's running like that last one I was working on that I was having trouble with. So you know, if somebody wants to put feet on it, rubber feet or whatever, they can do that themselves. I'm not going to bother doing that. The sander itself, I actually think this is a nice design with these adjustments here for the tracking. I think it's superior to what they're doing now with these little cam things and everything. So that I think gives this one an edge up. The bad part about this older unit is, first and foremost, there's no guard around the belt here and the pulley. This is all open. And there's also no dust shroud to go along the back side of the disc here, and there's no dust shroud to go along the bottom here. So you can hook up a shop vac and make it easy for dust collection. So that's a major drawback to this unit. And then, the other drawback is I've just got a short little piece of cord coming out of the motor right to a plug. There's no switch. There's obviously a spot right here or here that I could mount this switch pretty easily. I might even just put I might just get a cheap cord with an inline switch on it and maybe throw that in just to make it easy. But so this is going to be the cheaper of the two. This one on the motor, which is significantly bigger than the one next to it, has the ability to have this guard snapped into place. So I'll probably put this back on. But I think I'm pretty much done with this one, and what I want to do now is I want to focus on sander number 2, get that all straightened out, ready to go. Like to have the 2 sanders ready to go, and then basically advertise them and have somebody come down and take their pick between the two, you know. They want the older, sturdier looking unit with the bigger motor that they're going to have to deal with the dust, or do they want the newer unit with dust collection ability that has a smaller motor that we're going to have to figure out what's wrong with that motor too. Alright, we'll do a quick diagnosis of this motor. So the first thing I did was I took it off of its mount so that I can freely turn the shaft. And there's a little bit of squeaking in there. So ideally we wouldn't want that noise in there, but it turns freely other than that. So it's not a seized bearing issue. And oddly enough, it actually starts with no load on it. But it's got such little starting power that it's not able to start with the belt on it. In fact, I venture to guess that if I actually held it with my foot, I could actually keep it from starting. It's got no startup torque. I think I'm gonna take a look at this up here on the top. This may very well be a start capacitor up here. Well, I just opened this up and I unplugged the power, and then before I did anything else, I shorted the terminals there to discharge the cap in case there was a charge stored in there, so I could avoid giving myself a shock. And I saw a spark, so that would indicate to me that this capacitor is working. And it's not, this little seal right here isn't blown out. Sometimes when these capacitors go bad, they overheat and the contents, chemicals inside there expand and pop out this little vent. This actually looks like it's physically in good condition, but I am going to measure the capacitance, because maybe, even though it's storing a charge, it's rated right here 233 to 280 MFD. So that means it's supposed to be within a range of 233 to 280 or 90 microfarad. I can't quite read that, but I'll just measure it. And if it's way out of spec, then we'll see if we've got one that I can sub out and see what happens. Well, the range of the capacitance meter on my multimeter is not high enough to allow me to measure that capacitor. And the Z meter, my Sencore Z meter, is acting up, so, but I think that capacitance might be okay. But I still think there's a motor start up circuit problem with this motor, because even with the capacitor disconnected, it acts the same way, which is that it's barely wants to start, and then once it comes up to RPM, it goes like heck. And if I momentarily short those wires, which is, if that's the start capacitor, basically simulates the extra jolt that the cap gives when you first start it, it makes absolutely no difference. So I'm wondering if there's a centrifugal switch inside here that's the problem. So I want to take this motor apart on the bench and autopsy it, and got to disconnect the wiring, which is no problem because I don't like the way the wiring is on this thing anyways. So whoever wired this switch up, definitely, I doubt they were an electrician. The lead from the motor wire comes up, goes through a knockout in the switch box right here with no strain relief whatsoever. So over time, vibration can cause this metal edge here to wear through here, and there's no strain relief, so that's a no-no. I also don't even like the way that they routed it through this hole on the case here. Same reason. So what I'm going to do is I'm going to open up this box and disconnect this here. It looks like at least where the power cable goes into the bottom, they've got a correct Romex type connector down there. So I don't know if they just didn't have one handy when they were putting that together or what. This motor is what's called a through bolt design. So it means that once you take the 4 nuts off of the side and you knock these long screws out, this whole motor will split. And I could take this whole front piece out, this back plate off, and separate it all. So I did check. This is a dual voltage motor. I did do the obvious check and make sure that it wasn't wired for 220 volt inadvertently. And I also could see that it says to reverse the motor direction that you switch 2 wires.
which means that those two wires are going to be the wires that go to that start winding. Because basically the way it works is if the start winding's not energized and you power up the motor just kind of wants to sit there, and then the start winding will give it a kick to get it started in whichever direction you want, depending on which way the winding is set. It also, by the way, says that it's a ball bearing motor and that the ball bearings are permanently lubricated, so no lubrication necessary, which means that the bearings in here are probably trash. And one other thing I like to do before I split a motor like this is I mark the case with a Sharpie, a couple of index marks, so I can make sure when I put all these plates together that they line up the same way. So typically this back bearing is pressed into this cup back here, so when you're tapping this off, it'll pop off of that bearing. Once it pops off that bearing, then if you want, this whole front assembly can come out. Right now I'm going to leave it be. I am curious. You see, that front bearing doesn't actually sound bad at all. So it's definitely this back bearing is the bad one, and I'm not surprised. All the sawdust that's coming out of here is probably what killed that thing. So this type of motor here uses a centrifugal switch mechanism to activate the start winding and then take the start winding out of circuit once the motor comes up to speed. And the way it works is right here you can see this little leaf, this little copper leaf right here. When the motor's energized, the start winding kicks the motor over, the motor starts spinning. When the motor comes up to high enough RPMs, there's a centrifugal mechanism right here, a centrifugal switch mechanism over here, which I'm going to show you in a moment. So my suspicion, because it's such a basic circuit, my suspicion is that there might be a problem with the actual centrifugal mechanism. It may be stuck, and it may be stuck in a position where it's actually thinking that the motor's up to full RPM when it's not. Alright, so I've got the motor facing up so that we can get some light on the subject. First thing I want to mention is this waxy goop substance right here is what at some point in this motor's life used to pass for grease. And it's the consistency of earwax, and it has flowed out of that bearing. That bearing probably was getting hot, and it was pushing that grease out of there. And of course it was getting hot more than likely because of friction, because the bearing was already, on its way to failure mode. It doesn't actually sound that bad when you spin it like this, but it definitely doesn't feel as smooth as the front one. I'm going to want to maybe address that at some point. I don't know. We'll see how it runs. If I can get it running again, we'll see what it sounds like when it comes up to speed. Alright, so I dusted this off with an old toothbrush here so I can see everything better. And this is that disc centrifugal switch mechanism down here. And what's supposed to happen is when the motor is at rest, this disc will be all the way back like that. And so that disc will be pushing on this little finger right here, and it pushes this little leaf down and actually closes this upper contact, which is attached to the leaf spring, for lack of a better word, and cause that upper contact to touch this lower contact here. Alright, so I just went to switch my meter to continuity. So the other thing I'm curious about is whether or not there's continuity between the two connections for the switch when the motor is assembled. So right now, if I check this, well, it's interesting. I'm already getting continuity, and I don't even have the motor fully closed on yet. Why is that? Let me pull that back up some. That should go away. Yeah, there we go. Okay, so as soon as I slide this down a little bit, that switch is closing. That's normal. Alright, well, I just went through this whole thing, and everything seems to be absolutely normal. All the windings check out. So I'm either missing something, or maybe that centrifugal switch was stuck and it popped into position correctly when I took it apart. I don't know at this point. So the only thing I could think to do was to just temporarily reassemble it and try it again. So I'll try it right here on the bench. Now it seems like it's got the starting torque it's supposed to have. Maybe it's just a bunch of sawdust in there causing that thing to stick. Which makes me think I should even do a better job of maybe... Yeah, I think I should do maybe even a better job of cleaning the inside. Alright, I disassembled it again, and this time I took the whole front section out so that I can really get a good look at this switch. So my theory is that this was stuck like that, and that when I took it apart, I inadvertently caused this to pop out. Funny, that doesn't sound bad at all. I guess it is the front bearing that's noisy. Alright, I finished cleaning out the motor and it was chock full of sawdust, and then I decided to lubricate that plastic sleeve that centrifugal switch moves on, and I was real careful about my choices there. I didn't want to use an oil or a grease because that's just going to let dust and stuff stick to it over time and gum up. Ideally, I probably would have liked to use a dry silicone lubricant spray or something like that. I settled on just a little touch, not a lot, but just a touch of WD-40, and that thing's moving smooth as glass now. So I'm going to do one more check on the bench. I had to move it over to this bench because I got to get the vacuum out and vacuum off all the crud that's on the other bench that came out of this thing. Now there's no hesitation. It just has plenty of startup torque, so I'm going to mount it back in the frame.